Welcome to EGP channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I will discuss about the Norton's theorem. By using this theorem, how to solve the problem in the circuit. That is, first of all, you must know about the what is the statement of the Norton's theorem. It states that any linear network consists of a number of voltage current sources as well as resistances. That circuit can be replaced by a single current source in parallel with a single resistance. That current source is called as the Norton's current. That resistance is called as the Norton's resistance. How to find out Norton's current? At the given terminals in the circuit problem, you must short circuit the terminal, then find out the short circuit current. That current is called the Norton's current. At the given terminals, you must find out the open circuit total resistance. That resistance is called as the Norton's resistance. The finding of Thevenin's resistance and Norton's resistance both are same. If you find out resistance in Thevenin's theorem, that is called as Thevenin's resistance. If you find out open circuit resistance in case of Norton's theorem, that is called the Norton's resistance. Then after finding Norton's current and Norton's resistance, then you must draw the Norton's equivalent circuit, a current source in parallel with a resistance. Then across AB terminals, then you must replace the given circuit, nothing but the given element. Wherever you can find out the response in the given circuit problems, that open circuit terminals you must replace here across the terminals AB. Then in this circuit, in the Norton's equivalent circuit, a simple current source in parallel with two resistances. Then total current is Norton's current. Then at this node point, the current will be divided into two parts. One current is passing through Norton resistance and one current is passing through load resistance. Then simply you can observe, you can find out the current passing through any element by using current division rule. Then here in case of AC circuits also, the Norton's circuit, you can draw Norton's current in parallel with an impedance value. In case of AC circuit, you can find out the Norton's impedance. In case of DC circuit, you can find out the Norton's resistance. For suppose, in case of gate examinations, if we know the value of VTH, that is Thevenin's resistance, Thevenin's voltage VTH, as well as Thevenin's resistance RTH, then simply find out the Norton's current. That is, according to Ohm's law, V equal to IR. From that, Norton's current IN equal to VTH by RTH. This is also write down VOC, open circuit voltage, by Norton's current also. This Norton's current also you can also shown as short circuit current. If we know the value of Thevenin's voltage and Thevenin's resistance or Norton's resistance, then you simply find out the IN value, that is Norton's current, simply VTH by RTH. Or if we know Norton's current value and Norton's resistance value, then we can find out simple Thevenin's voltage, that is IN into RN. Okay, by using these two values, you can find out the another required value also. That is both Thevenin circuit and Norton circuit both are the dual networks. Dual means if the Thevenin's theorem, the circuit is a series combination, but in case of Norton's theorem, it is a parallel combination. In the Thevenin's theorem, it is a voltage source series with resistance, but in Norton circuit, a current source in parallel with a resistance. That's why both circuits are called as the dual networks. Then you can verify the Thevenin's theorem by taking a simple example. Here you can find out the voltage across 6 ohms by applying Norton's theorem. For example, here. What is the first step? Similarly, Thevenin's theorem also. In Norton's theorem, the first step is that is to find Norton's current. That is to find Norton's current. How to find Norton's current? That Norton's current you can find out by taking the short circuit. In the given circuit, where is the problem you can find out here? Across 6 ohms. That's why 6 ohms will be eliminated. How to eliminate? By simply taking as short circuit. Across 6 ohms, then the element will be open circuit deleted, and but that element you must short circuit here. But in case of Thevenin's theorem, it will be open circuited. But in case of Norton's theorem, it will be simple short circuited. Both roads are short circuited. Then through short circuited, you can find out the current passing through short circuit branch. That current is taken as IN, that is Norton's current. Then how to change the circuit here? Simple, observe here. After making short circuit across the element, then the short circuit forms across a resistance. Whenever a short circuit branch appear across a resistance, then simply delete the resistance value. Why? Because in the short circuit, voltage is zero. That's why both are in parallel connection. Hence, across resistance also, voltage will be zero. That's why you simply delete the parallel branch element. Then the circuit can be changed as after deleting the element, only you can place short circuit branch. That is 20 voltage source, 5 ohms. Then the short circuit branch current is IN simply. Then the circuit changes to a simple loop. Then you can find out the Norton's current IN here. That is simple I equal to V by R, total voltage by total resistance. Then the Norton's current is 4 amperes, 20 by 5, 4 amperes. Okay, like that, wherever you can find out the response. Response means our finding value, finding of current or finding of voltage. Then you simply short circuit that branch. Then you can find out the short circuit current through that branch. That current is called the Norton's current. Then after finding Norton's current, what is next step? That is step 2 is to find Norton's resistance. That is simply Rn. To find out Norton's resistance. The finding of Norton's resistance as well as Thevenin's resistance both are same. But how to find out the Thevenin's theorem? Simply wherever you can find out the response, simple you can delete that response, and also all sources are eliminated. In the circuit, the source is voltage source. That's why that voltage source must be deleted by short circuit. Hence, the node points will be element will be open circuited. At the open circuit terminals, you can find out the Norton's resistance across open circuit terminals. Simply observe here 5 ohms and 10 ohms. How to form? Both are in parallel connection. Both elements are connected between the same nodes after deleting voltage source. Then both elements are parallel. That's why R1 R2 by R1 plus R2. Then that Rn value is 3.33 ohms. This is the Norton's resistance value. After finding Norton's current as well as Norton's resistance, then what is the next step? That is step 3. That is to draw Norton's circuit. That is Norton's equivalent circuit. To draw the Norton circuit. How to draw Norton circuit? The Norton circuit is the finding current value, that is IN, in parallel with finding resistance value, that is Rn. Then across the circuit you can replace the deleted element here. What is element deleted in this problem? That is 6 volts will be deleted. Then Rn value is 3.33. Then IN value is 4 amperes. Then simply here IN becomes total current of the circuit. Then the circuit will be deviated at this node point. Then the current passing through Rn is, that is IR. The current passing through 6 is taken as I6. Okay, before going to find out the voltage value, then you must find out the current passing through 6, that is I6, equal to, what is current division here? Here you can apply the current division rule, that is total current into opposite value, that is Rn 3.33 by total resistance value 6 plus 3.33. Then that I6 value is 1.43 amperes. That is the current passing through 6 ohms. Then after finding the current passing through 6 ohms, then our find out our required value. That is, what is the voltage across 6 ohms? That is V equal to I into R. Then R value is 6, current value is I6. Then 6 into 1.43. Hence the voltage across 6 ohms is 8.58 volts. Then in this way you can find out our required value in the given circuit by applying Norton's theorem. In the same AC circuits also you can find out the Norton's theorem. That is, wherever you find out the response, simple that element will be short circuited. Then find out the short circuit current, that is IN. After that, open the elements, then find out the open circuit resistance, that is the Norton's resistance, by eliminating all sources. If the current source is there, open circuited, voltage source is there, short circuited. Then draw the Norton's equivalent circuit, then apply current division rule, then find out the our required value. Please subscribe our channel and share to your friends.